Hello everyone, welcome to Imaginary Hub. I'm Jabir. In this video, we have brought you a complete recursion series. Now we have divided this series into two different videos. In the first video, we are going to talk about recursion basics like what is implicit stack, explicit stack, stack overflow, and all the basics related to recursions, how recursions work, and we are going to see some basic problems based on recursions. After that, in the second part of our video, we are going to talk about top questions related to top questions which are asked in the interviews, and you can find those questions in LeetCode and HackerRank like platforms, and we are going to discuss the top level questions in the second part of video. Those questions are based on recursions. So with that being said, let us start our recursion first class.
Hello everyone, now we are going to start our next chapter, that is recursions. So recursions is a very important chapter, when it comes to placements and interviews, and the interviewer might ask you like direct problem of Fibonacci series or any kind of tiling problem or friends pairing problem. These are the like famous problems for recursion topics, and these are the basics these are the fundamentals for our upcoming chapters. So recursion is the base of our upcoming chapters like trees, graphs, DP, and all those things. So understanding recursion is very important, and I want to tell you one thing, that if you study recursion perfectly, that you understand the concepts of recursion and what is going on and how we do recursion and why we do recursion or when we do recursion. If you understand these sort of things, then I can guarantee you that you will become a excellent programmer. And personally, if you study recursion topics in deep, then you understand and you can see that you will see the growth in yourself, right? So recursion is a very important topic, and if you master the recursion topic, then you will become an excellent programmer, and you will start to think on your own that how I can solve or how I can approach a particular given problem. What is the correct way? What is the wrong way? You can be able to differentiate the correct way and the wrong way to approaching a problem. So recursion is a very important chapter, and it is an excellent chapter. I'm telling you that you are going to love this chapter, right? So from my perspective, this is my favorite chapter, because this has this is the fundamental, and these recursion topics or recursion methods is used in topics like trees, graphs, and dynamic programming and all those things. So remember guys that recursion is the base for like complex topics like trees, graphs, and all those things. So understanding recursion is very important. So I want you guys to listen to this chapter carefully and understand and make your notes on your own, such that you will understand, you can revise the things which we are going to discuss in the upcoming chapters. So with that being said, now let us start this chapter. Now let us understand what is the meaning of recursion. So mathematically, we used to write functions, right? We know that we describe a particular function like this. So let us consider a function that is f of x is equals to x square, right? Okay, f of x is equals to x square. This is a particular function. Now, can I write our function? This is known as domain. And I'm going into like mathematical terms of it. But you don't. If you're not a mathematical student, if you're not from mathematics background, then this doesn't matter to you, right? So this is, you can imagine as this is the input. So f of x is equals to x square is a function. So I can write my function as f of x. Right here, I'm calling my function. Here, the inside parameter is the function itself. So this thing will give f of x square. So if f of x is equals to x square, then x square, that is x square, then f of x square will give x square whole square. That thing will give me 4. Let us take example that x is equals to 2. Then f of 2. So f of 2 is equals to, what is f of x? That is 2 square, right? That is x square. That is nothing but our 2 square. So this thing will give me f of 4. So what is f of 4? F of 4 is 4 square. So this thing will give me 610. So f of 2 is known as f of 2 will give me value as 16, and this sort of thing is known as recursion. So calling our function, a function calling itself, that is known as recursion. Now let us take another example. Right, in previous questions, in previous chapters, we have studied right how to calculate a factorial of a given number. Now, in mathematical terms, I am going to represent it. Let us consider that I am calculating the factorial of a n and n number. So, I can write that my f of n, that is factorial of nth number, is equals to n into factorial of n minus 1. Right, and I can write this function, this f of n minus as f of n minus 1 factorial of n minus 1 is equals to n minus 1 into f of n minus 2. Yeah, this is also absolutely correct. So I can write my function, that is f of n minus 2 is equals to n minus 2 into f of n minus 3. Yeah, right, okay. So can I write my f of n minus 3 as f of n minus 3 is equals to n minus 3 into f of n minus 4, and this process will continue up to we get f of n minus 1, that is 1 into f of n minus 1, that is f of 0, and at f of 0 we already know that 0 factorial is equals to 1. So this thing will give me 1 into 1, and we will return the value, and by returning the value we can able to calculate our f of n minus 1 factorial. Now let us take example to understand this. Let us consider that f of 5. So let us consider that I don't know the factorial of 5, because let us consider that I don't know the 5 factorial value. So if I don't know, the concept of recursion is, first of all, if you don't know the answer for a huge problem, then break it into small pieces. Right? Break it into small, tiny pieces, and combine those by finding the solution for those small pieces. By combining those small pieces, you will get the solution for your large problem. So this is the basic concept of recursion, and this sounds like familiar to integration. In integration, we also do the same thing, right? To calculate the area of a particular given curve, we can't able to find like right away the area of curve. We like break it into small rectangle pieces, and we'll add them together such that we'll get the area of the integration. So if you're not from integration background, then leave these things. So the main concept of recursion is, if you don't know the problem, the answer of a huge problem, then break it into small pieces and try to find the solution for that particular small piece. So if you're able to find the particular small solution, the small problem solution, then just combine with all those small tiny pieces, and by combining you will get the final answer of your huge problem. Now let us consider that I want to calculate the 5 factorial, and I don't know, because this is a huge problem for me, because I don't know how to calculate 5 factorial. So what I do, this is my 5 factorial, right? F of 5. So I will write, I already know that my formula, that f of n factorial is equals to n number, that is the number itself, into f of n minus 1. So I try to find out the factorial of f of n minus 1. So what I will try to find? I will try to find the factorial of, that is n minus 1, that is 4 minus 1, that is 4. So I will try to find out the factorial of 4. So I don't know the factorial of 4. So what I can do, I can write 4 into factorial of 3. Yeah, but I don't know the factorial of 3. So I can write 3 into factorial of 2. Yeah, but I don't know the factorial of 2 also. So can I write that factorial of 2 as 2 into factorial of 1? But I don't know the factorial of 1. So can I write as 1 into factorial of 0? And yeah, I do know that factorial of 0 is equals to 1. So here I will multiply 1 into 1. So this thing will give me 1, that is 1. So I will return to my like upper program, or whatever the previous call program, right? Previous function. So this thing will give me, I already know that this thing will give me 1. So this thing into 2 into factorial of 1 is, from this I have calculated that this thing will give me 1. So final answer will be 2. After this thing will get like this thing will get here multiplied with the answer, that is 3 into 2. So this thing will return me 6. So the answer here 4 factorial is equals to 4 into 6, that is 4 factorial is 24. So I will return the answer to my 4 factorial, and the final answer will be 5 into 4 factorial. What is 4 factorial? We already found out that the 4 factorial is 24. So the answer will be 120. So the 5 factorial value is 120. So calling our function, right? I am going to call my function itself. So a function which is calling itself and calling, the calling continuously happens until we reach a base case. What is base case? At small tiny piece, I know that particular solution. Those particular small tiny piece, or you can say that small problem solution I know. So that small problem, that thing is known as my base case. Here f of 0, I already know that for this problem, that is 0, for finding 0 factorial, I already know that the answer is 1. Right? If I know that small tiny piece problem solution, then that thing is known as my base case. So remember guys that a function which is calling itself, this process is known as recursion. So a function recursively calling itself, that is known as recursion. Okay, and in recursion we have a base case, and from the base case we can able to find the solution of a small piece, and combining all, you can see that I have passed 1 factorial to here to my previous calling function, and I have calculated 2 factorial and passed to 3 factorial, and I have calculated 3 factorial and passed to 4 factorial, and from 4 factorial to 5 factorial, and finally I got my desired answer, that is finding my 5 factorial. So this is how recursion or a recursive function takes place, right? This is how it will take place. And there is one important thing I want to tell you, that there are two directions. There are two directions in recursions. You can see that first of all I am going inside of my function, and second direction is I am coming outside of my function. So the first thing is top to down, right? I am coming from the top to down. I am breaking my big question into small piece, and finally I am finding the solution for the smallest piece, and I am returning towards the big piece, and from the small piece I can able to calculate the big piece or big problem for my question, right? Okay, from first direction is top to down. Here what I am calling, here I am traveling towards the base case. So from top to down, you can see that from a huge problem I have been reducing my problem to my base case. So if I got my base case, then I will start to expand again. So this thing is known as solution. This second direction is known as solution combination. So whatever the solution I get, I am combining to get my final output or final solution. So second thing is known as solution combination. So these are the two steps that are involved in our function calling or function recursive step. So these are the two directions that are very important. That is, first of all, I am breaking my problem to my smaller pieces, and I am expanding from it. Now let us go into the definition of recursion. Recursion is a method of solving computational problem where solution depends on solutions to smaller instances or smaller pieces. You can write here smaller pieces of same problem. You can see that for finding 5 factorial, I have calculated 4 factorial. For 4 factorial, 3 factorial. For calculating 3 factorial, I want to calculate 2 factorial. For 2 factorial, 1 factorial, and 1 factorial. For 1, I have calculated 0 factorial. So you can see that the thing which is going on, that is calculating factorial. Those things all are similar in all over the program, all over the function. What I am finding the factorial of a given number. So you can see that the thing which I am going to calculate is similar throughout the function. So that is known as similarity. So here in recursion we are doing our problem on a similar things, and we are going to break our small huge solution into small pieces, and from the small piece we can able to find our big solution. We have to believe that, right? My small solution, right? If I don't know the 5 factorial, then I will call for 5 factorial into factorial of 4, and you have to believe that my 4 factorial, that is my 4, calling my 4 factorial function will return the 4 factorial, and after it 4 factorial will call f of 3, and you have to believe that my 3 factorial will return the factorial of 3. So you just have to believe, and there are 3 things which are very important when it comes to solving recursion questions. In previous chapter, in pattern chapter, I told you, right, there are 3 things in like pattern solving any kind of pattern problems. Similarly, here we have 3 things or 3 statements which you have to remember to calculate or to do any kind of recursion questions. That is, first thing is base case. So you must have to know you must have to know that what is my base case. So if you don't know the base case, then our function calling will continuously start, and these will impact, or this will result in stack overflow. So we will study about stack overflow in the next video. So you should know what is your base case, what is your final case, what is the minimum problem solution that you already know. So by finding or by knowing the solution of the smallest piece, you can able to find the largest piece or largest problem of your like given question. After second one is work. In the function calling, what work you are performing? Here I am performing 5 into factorial of 4. Here I am performing 4 into factorial of 4. Here what I am performing? I am performing multiplication operation with my integer into my function call. So this is how the work I am defining. So you should be very clear. What is my base case? Second one is what are the work I am going to do in my recursive function. And the third one is function calling, inner function calling, inner function call. That is, I am calling f of n minus, right? So you should know that why I am calling, you should know the logic, right? Why I am calling this f of 4. So to calculate a function of a particular factorial of a given number, I need to know f of n minus 1. Here, that's why I am calling this kind of inner type function, inner function calling. Right? That's why I am calling this recursive method. Right? Here, you should know that these three things. Right? What is my base case? What is the work I am going to do, and why I am calling my inner function like this? Why not the other way, or why not this particular way? So you should know these three things, right? By knowing these three things, you can understand, or you can go through like many of this question, right? Remember guys that what is recursion, and what is recursion? Recursion is nothing but to calculate the huge problem, we break it down into small pieces, and we reach our base case, and from the base case we will combine all our solutions to get our final solution, right? So in memory, this is the recursion happens in the form of stack, like I am drawing this in a general way. So this is my main program. Main program will call my function, and my function will call again the function itself, the same function. After it will call function, and another function will also call the same function. After the function will call the same function until I reach base case. So if I get the base case, then it will return some value. After it will return some value, and this will also return some value, and finally I will return to my main program, and whatever the value I have written here, that should be my solution. So this is how recursion concept works. So before we do the questions or learn the concept, what is going on in recursion or how recursion works, you should know two concepts. You should already know, right? You should have studied two concepts that are, first one is iteration. Iteration, or in other words, you should know about loops, right? You should already have studied like loops, what is for loops, what is do while loop, what is while loop, and if you studied these three things, then well and good. After that, second one is how we call a function, or what is function declaration, definition, or calling, or how we call a function, or how we give parameter, how we pass array. So if you know these two chapters, then we are luckily ready to do our chapter recursions. So I want to tell you one more thing, that if you know like iterations and recursions. Recursions are like siblings. So you can solve any given problem using iteration approach or recursion approach, right? If the interviewer particularly asks you that you have to do this problem using iteration approach only, then only you should proceed with like iterative approach. If the interviewer asking you that you should do this particular question using recursive method only, then you should proceed with recursive approach only, right? Whatever the questions we are doing in recursion chapter, you can do those questions using iteration method also. So whatever the questions we did in iteration chapter, we can do this using recursion approach. So if a particular question is being solved by iteration, then it can also be solved by using recursive approach. So you can solve the given problem using any one of these two. So based on our scenario and based on our like approach, which is based on our like difficulty. If that particular approach is easy for that particular question, then we will proceed with that particular question. Suppose for trees, for like searching a node in my tree or searching like a level wise traversal, I will use recursion approach because it is like kind of easy, whereas iterative approach is like kind of hard for like searching or level wise traversals for my trees. So for that, in some scenarios I will use recursion, and in some questions iterative approach is very efficient. So depending on the question type or depending on the way question asked, we use iteration or recursion for that particular question. I hope you have understood. Like to do this chapter, you should know two chapters before, that is iteration and functions. If you studied like iterations and functions, then you are good to go, right? Let us talk about the approach for this question. So we need to print the numbers in decreasing order. Let us consider that user has given me 10. Then I need to print like 10, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So in this fashion, I need to print my output. So what is the approach? What is the recursive approach for this question? Right? I told you that there are three main things in our recursive topics. In these three conditions you have to remember. Right? The first condition is a base case. What should be your base case? Second condition should be work. What work you are going to perform in our recursive approach. And third one is how we are going to like call our inner function. So these three things, if you are clear, or right, for a particular question, if you are clear with these three things, then you can solve any given question. Now, this is my given question, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? Okay. Now, I need to print these numbers in decreasing order. So, what is the approach, or how I can like approach a particular question? Right? Suppose user has given me 10. Then, let us consider that this is my function public static. Like I'm printing, right? So void decreasing number. Right? In this, I'm passing my value of n. So first of all, in this question, whatever the user has given me value, I need to print that value. So let us consider that this is my output. So first of all, I need to print my value, given value, right? So I will print my value and I will call my like a dec n minus 1. So for n minus 1, I will print n minus 1, that is I will call dec 9. And for dec 9, I will first of all print 9 here. After that, I will call dec n minus 1, that is dec 8. Right? So I will when the n value is 8, I will print 8. After that, I will call dec 7. Right? When the n value is 7, I will print 7. After that, I will call dec 8. Dec 6. So I am going to decrement the value at each function call. Right? I will print 6 here. After that, I will call, after printing, I will call dec 5. So here I will print 5. After that, I will call dec 4. Right? Here I will print 4, and these process will get continue until my base case. Until I hit my base case. That is when I call dec 1. If n is equals to 1, if given n is equals to 1, then simply print that value of n, that is 3, 2, 1. Yeah, print the value of 1. After it return. That's all. So first of all, what I need to do? First of all, I am printing the value of n. So I am going to print system.out.print n value. After that, I will call my dec print. Dec print is my function name, right? Dec print. In this, I am calling my n minus 1. Right? I am calling n minus 1. After that, the base case here is if my n is equals to 1, then simply print the value of n. After that, simply return, come out of my program. That's all. So this is the pseudo code. For my given question. Now let us code this thing. After that, we will analysis how memory takes place and how call stack takes place in recursive approach for this particular question. So in this, first of all, I am going to create my dec print function. For that, I am going to create my public static void dec print. In this, I am passing n value. After that, here first of all, let me write my base case. So the base case is if my n value, that is n is equals to 1, then basically system.out.print print the value of n. After that, return. Simply return come out of my program. Else, if my n is not equals to 1, then I need to do my work. The second step is work. So here I need to print system.out.print value of n. After that, after doing my work, I need to call my inner function call. So this is my top step. So I am going to call my inner function. So simply call dec print n minus 1, right? Save this thing, and here I am going to give int n is equals to 10. After that, I am going to call my dec function. In this, I am passing n value. Now let me save this and run. You can see that I have printed 10, 9, 8, 7, 6, 5, 4 from 1 to 10. So this is how the base case, if n is equals to 1, then return the value of n. After that, what work I am doing, if that particular n value is not equals to 1, then it will came out of it don't go into for if loop. After that, it will print the value of n. After that, I will call my inner function for n minus 1. Suppose, let us consider that n is equals to 10, then I will call, after printing the value of 10, I will call for 9, and I will print the value of 9. After that, I will call 8. So these process will get continue until my n value will become 1. If my n value become 1, then I will come into my if statement. After that, I will print the value of n. Finally, I will return my loop. I will return my function. I will return or came out of my function, come out of my function. Now let me explain you in stack format. Recursion calling takes place in stack format. Now let us do a little bit like a dry run kind of thing for my given code. Here this is my base case, and this is my work, and this is my inner loop. So these are the three things that I have told you. Now first of all, the control is in main program. So in the main program, this is my main program. So function calling takes in the form of stack. So you can see stack in everyday life. Here we have a pile of books. So putting books on top of each other, that is stack of books. You can see that some people play games like they put stones on top of each other. That is a stack of stones. Similarly, here what I will do here, the function calling takes place in the form of stack. So initially the control is in main program, right? Main program. After that, here whatever the variables we have in the main program, that is n is equals to 10, will get passed to my dec function. Dec function, here the value is 10, right? Here let us consider that this is my output. Here if I am checking n is equals to 1, no, here n value is 10. Okay, n value is 10. So it will not go into my if statement, and it will come and print the value of 10. So what I am doing, I am printing the value of 1. After that, again I am calling my dec of n minus 1, that is 9. Now n is equals to 9. Here n is equals to 10. Right? Okay. This is my dec now. So I am checking if n is equals to 1. No, n is not equals to 1. Then what I am going to do, I am going to print the value of 9. After that, I will call for 8. So my dec will become n minus 1, that is dec will become 8 now. So n is equals to 8 now, right? And again I am checking if my n is equals to 1. No. Again print the value of 8 and call for 7. So dec of 7. Here n is equals to 7, right? Again n is not equals to 1, print the value of 7. After that, here n will become 6 and dec of 6, right? Again not equals to 1. So n will is equals to 5 and dec of 5. So here I will print 6, after that 5, and again dec of 4 will get called, and n will become 4. After that, here n will become 3. So dec of 3, right? Here I will print value of 4, after 3. Again here I am getting out of the board, but yeah, dec of 2. So n is equals to 2. N is not equals to 1 again. So I will print the value of 2. After that, I will call here again n. For this is my final call, I am writing here that dec of 1. So here n is equals to 1. Yeah, the value of n is equals to 1. So what I will do, I will print the value of n. First of all, in the if statement, print the value of 1. So I am going to print my value of n. After that, I will return from 1. I will return here. After that, I will return this value, this control will get returned like this, right? Right? Finally, to my main program. So you can see that I am going from top to down, and I am combining all my solutions. I am printing the value of 10. So by returning the final flow or the control will be on main program, and you can see that I got my output like this. So this is how the stack calling works for my recursive functions. Now I want to tell you a little concept of stack overflow. There's a concept of stack overflow. So when we are studying recursions, it is very important to understand what is stack overflow. Right? Stack overflow is nothing but when we call like many stacks such that our memory will get full. That is nothing but stack overflow, and there is no space to store any variable or any kind of like method or any function calling. There is no space for any function calling. There is no space, or there is no space for creating a variable. Right, that condition or those kind of things is known as stack overflow. Let us consider that I am calling like main function. From the main function I am calling my function, and again from the function I am calling my function, and from the function I am calling my function, and these function calling taking place. And when I got why I get stack flow for a particular recursive function. The reasons why we get stack flow is, first one, file size or like parameter, huge parameter. So the first condition is huge parameter. So if I'm like calling or passing parameter like a size of like 1000 or 10,000 array elements, then these parameter is full. So at every call, every function call, these parameter is passing, right? So if I pass a huge parameter, then there is a probability that I will get stack overflow. After that, second one is too many function calling. Too many function calls. So if I'm calling like at the same time I'm calling like 10 function calls, then I will get like a stack overflow condition. And the third condition is if there's no base case. So these are the three conditions for which we will get stack flow. So if we are passing a huge parameter, then there is a probability that we will get a stack overflow. After that, the second condition is too many function callings. Like if I'm calling at the same time I'm calling like 1000 functions, then it will give me like a stack overflow condition, right? And the third one is if there is no base case. Suppose I'm calling a function. In the previous example, you can see that the base case is if n is equals to like n is equals to 1, then what I'm doing, I'm returning, right? Okay, suppose let us consider that there is no base case. Then what output will get? We'll get right 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, minus 1, and this will continue up to minus infinity, or my stack will get overflow, and these like stack will get full, and it will show us error that there is no space for like storing or printing any function call in my recursive function. So it will show us error, and it will occupy all the memory in my computer. So if any of this condition is true, or if any of this condition will happen, then our program will show us a stack overflow condition. Now let us do our second question. So that is this is like similar to my first question only. Here what I am doing like first of all here in the place of increasing, in the place of decreasing, I need to print numbers in my increasing order. Suppose like a user has given me n is equals to 10, then I need to print my numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how I need to print my numbers. So the approach is same, right? The approach is same, but there is only like a small line difference. Now let me write my function. First of all, I will write my pseudocode, that is public static void increasing. So in the increasing function, I am passing my parameter int n. After that, I am checking if my n, this is my base case, if n is equals to 1, then what you will do, print system.out.print value of n. After that, return. That's all. After that, first of all, in the previous question, what we used to do, we used to print the number. Here we are not going to print. First of all, we'll call the function. After function calling, we will print. Right? So first of all, we'll call increment or increasing order n minus 1. After that, we will print system.out.print value of n. So this is how the pseudocode here. The only one change, interchange in line, will give me the numbers in decreasing order or in increasing order. Now let me code this thing. Here I am going to write increasing order. So I am going to create my function public static void ink print. In this I am going to pass my n value. After that, first of all, I need to find out my base case. So my base case is if my n is equals to 1. If this condition is true, then what we have to do? We need to print system.out.print print the value of n. After that, return, come out of my program. Right, that's all. After that, what work I need to do here? Right, before I need to do work, first of all, I am going to call my inner function. Right, function calling, right, I'm going to call increment n minus 1. After that, my work, what is the work I'm doing? I'm printing the value of n. That's all. Now in the place of calling, print the value of n, and in the place of calling decrement print, now I'm printing or calling increment or increasing order pattern. Now let me save this thing and run. So you can see that I got my output as 1, 2, 3, 4, 5. So up to 10. So this is the code for printing numbers in increasing order. This is the code. Right. Now let us solve our next question. Let us do a stack analysis, and let us understand how the function calling takes place in our program. So this is my base case, and this is my inner loop calling. After it, inner function calling. After it, this is my work I'm doing. Now here initially the control, let us consider that this is my output. Now initially the control is in main program. The value of n is equals to 10. Right, now I am calling my function, that is increment 10, increment print. So increment print will store the value of 10. After that, here n is equals to 10. So this thing will call, this thing will check if n is equals to 1. Yeah, no, n is equals to 10 here, so it will not go into if statement. After it, the second thing is the flow comes from top to down. So here you can see that I am calling my function first. So here it will call increment, it will pass 9. After that, n will become 9. After that, here I will pass inc 8, n will become 8. After that, inc 7, so n will become 7. So these function calling takes place like this. Right, after that, inc 6, here n is equals to 6. After that, inc 5, n is equals to 5. After that, inc 4, n is equals to 4. These function calling will continuously go until I reach my base condition. So inc 3, n is equals to 3. After that, inc 2, n is equals to 2. After that, inc 1, now n is equals to 1. You can see that here, if the inc is equals to 1, then print the value of 1. Right, print the value of n. So this thing will print me the value of 1. So in the output, I will get value of 1, and the control will get hand over to my this previous call function. So this is my previous call function, right? So the function control will come to n is equals to 1 to my previous call, my previous function call. So from this, here I will print the value of n. So what I am doing, you can see that I am printing the value of n. So I will print 2. After that, I will print 3. After that, I will print 4. After that, I will print like 5. After that, I will print 6, 7, 8, 9, and finally I will print 10. So the output will be 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how from top to down I have been like calling my function until I reach my base condition. If I got my base condition, what I am doing, I am printing the values of n. So from base case, I am returning back, right? As I return back from the base case, I am printing the value of n at each function call, right? Okay, this is how I am printing, and this is the work I am doing in this program. I hope you have understood like how stack works. Right, let us do our next question. So in this question, I already noted to calculate the factorial of a function. In the beginning itself, I told you, right, factorial of n is equals to n into factorial of n minus 1. Right, okay. Here the code will be the pseudocode, right? I will calculate the n minus 1 value, that is n minus 1 into factorial of n minus 2, and this continuation function calling will take place until I get factorial of 0. So we already know that factorial of 0 is equals to 1, and this will become my base case. Right? This function call will continuously takes place until I got my base case. After it, from that I will calculate the factorial from function calling to my previous or returning control to my previous functions. Right? This is how the code or the concept of factorial of a calculating of a given number work. Now let me write a pseudocode of this question. Right? First of all, I will write public static int type function, because I'm going to write give return integer type function to my user. After that, I'm going to write fact. In this, I'm passing n. So what is my base case here? That if my n will become 0, if my n becomes 0, then I'm going to return 1. That's all. Else, this is my base case. This is my base case. After that, I need to calculate the factorial of n minus 1. Right? Okay. So we need to calculate int factorial of n, factorial of n, factorial of n minus 1. So this will become fact of n minus 1. So I am calling my function. After that, what I am doing, I am calculating my factorial, that is f of n, factorial of n is equals to n into that is nothing but factorial of m minus 1. It finally return whatever the value I got as my function in my function calling. So this is the pseudocode for calculating the factorial of a given number. Now let us code this thing. I'm going to write factorial. Right? First of all, I'm going to create my function public static int type function, because I'm going to give a return an integer. After that, fact. In this, I'm passing int n. After that, here the base case is, first of all, base case is if n is equals to 0, then return 1. That's all, return 1. After that, I need to calculate my factorial of n minus 1. For that, I'm creating a variable that will store the factorial of n minus 1. So factorial of n minus 1 is equals to fact of n minus 1. After that, what work I need to perform? I need to calculate, this is my function calling here. Here, this is my inner function call. Okay, and here I need to do my work. What work I am performing? The work I am doing is int and calculating the factorial of the number. That is int factorial of nth number is equals to n into factorial of n minus 1. That's all, and finally return fn, factorial of nth number. Now here I am going to pass n is equals to 5. So in the first video we have written that the factorial of given n is equals to 5 is 120. Right? I am going to print whatever the value that my function return, factorial function will return. Now let me save this thing and run. So you can see that I got my output as 120. So this is how we will calculate the factorial of a given number, and this is the program for calculating the factorial of the given number in the recursive approach. So we have studied iterative approach and the recursive approach of calculating factorial of the nth number, right? Now let us do a stack analysis for my factorial of the given number question. So this is the code, right? So public static int. In this we are passing the n number to find the nth factorial of the given number. Yeah, in the previous example we have passed like 5, right? And we got our answer as 5 factorial as 120. So in this, first of all, we are considering our base case, that is if n becomes 0, that we already know that 0 factorial is equals to 1. This is our base case. So in this case, return 1. After that, I am calling my inner loop for n minus 1. After that, here, this is the work I am doing. This is my inner call and this is my work. After that, finally, I am returning the factorial of the nth number. Now, let us do a stack analysis. First of all, the flow or the control is in my main program. And n is equals to 5. Right? So, here I am calling my function, that is factorial of nth number. Here, factorial of nth number, and I will pass 5. So here I need to find out 5 factorial, but I don't know. You can see that here n is not equals to 0, so it will not go into if statement. After it will come out, and I am going to calculate f of n minus 1 factorial. So f of n minus 1 factorial, that is I am calling f of here n is equals to 5. Now I am calling factorial of 4. So I also here n is equals to 4, and I don't know the factorial of 4. That's why again a stack call will take place. Here n will become 3, and I am calculating factorial of 3, but we don't know the factorial of 3. So again a stack call will take place, and n is equals to 2 and factorial of 2. So here you can see that n is not equals to 0. So So these call frames will continue until we get the base case, until we touch our base case. So n will get reduced to 1, n will become 1. After it, I am calling factorial of 1, but I don't know the factorial of the given number. So here n will become 0 and factorial of 0. Right, factorial 0. So when n is equal to 0, what I am doing, I am returning 1 here. After it, I am calculating this. Now I am doing work. So after calling all my inner calls, now I am doing my work. Right, I am performing my third step. That is factorial of n is equal to factorial of n is equal to n into factorial of n minus 1. So factorial of n minus 1 is nothing but n. I am calling, right, those values I am returning. Right, I hope you have understood. Right. Factorial of n is equal to n into factorial of n minus 1. So whatever the value that my call stack will return, that will become a factorial of n minus 1. Okay, right, here I will return 1. After that, I am performing n into 1. So this thing will return me 2. So here I am performing n value is 2, and here this value will give me 1. So 2 into 1. So here I will return 2. After that, here n value is 3. So 3 into the return value, that is 2. So here from this I will return 6 and multiply it with n value. Here n value is 4. So I will return 24 here and I will multiply it with 5. So finally I will return the value to my main program, that is 120. So this is my answer. So this is how call stacks, all call frames, a box of this, each box is known as a call frame. A call frame. So this is how call frames or calling our inner functions take place. After that, whatever the inner function returns the value, I am multiplying with the current n value. Right, here you can see that the n value is 1 and the return value is also 1. So I am multiplying 1 into 1. But you can see that here n value is 5. But I am multiplying with the returned value. Here the returned value, that is nothing but factorial of n minus 1 is equals to 24. So I am multiplying with the 5 into 24. So these thing will give me 5 factorial. So this is how I can able to calculate the factorial of the given number. Now let us dive into our next question. That is, in this question we have to print the sum of n natural numbers. Now let us take example that how we can calculate or what are the things that we need to understand before we dive into the logical part of this code. So let us take example that user has given as 5. So n is equal to 5. Then sum will become 5 plus 4 plus 3 plus 2 plus 1. That is nothing but 5 plus 4 plus 6. So 9 plus 6. So these things sum will become 0. When n is equal to 5, sum will become 15. Sum will become 15. So I need to return 15 to my user. So can I write that, let us consider that I am creating a function to calculating my sum of n natural numbers. Let us consider that sum of n natural numbers is equals to n plus sum of n minus 1. Right, this is the logical thing. Right, suppose let us consider that I need to calculate the sum of n first 5 numbers. So can I write that my sum 5 is equals to 5, sum of 5 is equals to 5 plus sum of 4. So if I find a way to calculate these sum up to 4 numbers, sum of first 4 numbers, then it can be possible to calculate up to the 5 numbers. Right, so what I do, I will just add and I will do a recursion call for the rest of the numbers. So to calculate the rest of the numbers, I will call my recursion. Right, and I will add whatever the value these things will return, I will add with my 5 value, and these things will give me the sum of the given number. Okay, this is the logical part of this question. This is the logical thing. Right, so can I write that sum of 5 is equals to sum of 4? Right, how we can calculate sum of 4? Can I write that sum of 4 is equals to 4 plus sum of 3, and sum of 3 is equals to 3 plus sum of 2, and sum of 2 is equals to 2 plus sum of 1, and sum of 1 is nothing but 1. Right, so when this is my base case, this thing is my base case. So the pseudo code, I hope you have understood the logic that recursion calls will take place until we get our base case, that is sum of 1. So if I call a function that is n value will become 1, then that is my base case. From that I will return 1. Right, so from this I will return 1. So this value will become 1 and this thing will become 3. So sum of 2 will become 3. Here this value will become 3. After sum of 3 will become 6. So I will return 6 here, and sum of 4 will get 10. Right, after here I will return 10. After I will add 4 plus 10. So this thing will give me 10. So sum of 5 will become 15. So let me represent it in a clear diagram. Right. So yeah. So can I write one thing that sum of 5 is equals to 5 plus sum of 4, and sum of 4 is equals to 4 plus sum of 3, and sum of 3 is nothing but 3 plus sum of 2, and sum of 2 is nothing but sum of 2 plus sum of 1. Okay, and this thing will return me, this is my base case, so this thing will return me 1. So I already know that when sum of 1, when n will come 1, then sum of 1 is equals to 1. This is my base case. Right, from this this thing will return me 3. After 3 plus 3, so this thing will return me 6, and 4 plus 6, so this thing will return me 10, and sum of 5 will become 5 plus 10, so sum of 5 will become 15. So this is how call tags or calling our inner function works. Now let me write the pseudocode for this thing. So I am going to return the value of my sum, right? So I am going to create public static integer type function. After it, let me write the function name as sum. After it, here I am passing int n. So the base case here, base case is if our n is equals to 1, then return n. Right, this is my base case, and what I need to do, I need to write just simply return the value of n plus sum of n minus 1. So I am writing this whole thing in a single line. I hope you have understood, or I can write this particular thing in a long form also if you want. I hope you have understood the base case. Now I am going to expand this thing. If you have any problem with this single line, I am going to expand it such that it will become even more clear to you. So here I am calculating sum of n minus 1. So int sum of n minus 1 is equals to or in other words, int sum of n is equals to n plus sum of n minus 1. Right, after return sum of n. That's all. Now let me code this thing. I hope you have understood the logic. Now if I code when we code this thing, it will become even more clear to you. Now let me create my function for sum of n natural numbers. So first of all, I am going to create my function public static int sum. In this I am passing int n value. After it, first of all, let me write my base case. Base case is here I need to use static. Yeah, static. After it, here public. So in the base case, if n is equals to 1, then return n. Right, after it, my inner function calling, call, and I am doing the work at the same time. Right, work in the same statement. So int sum of n is equals to what I told you, that sum of n is equals to n plus sum of n minus 1. So n plus sum of n minus 1. So I can write it as a sum of n minus 1. Right, okay. After it, finally return sum of n. That's all. Right, here I am passing n is equals to 5, and I am printing whatever the value returned by my sum function. That's all. Now let me save this thing and run. So you can see that I got my output as 15. So this is my function to calculate the sum of n natural numbers, and here I am in the main program I am passing n is equals to 5. After that I am printing whatever the sum value that got returned by my sum function. I hope you have understood the logic and the working. Now let us do a stack analysis for this thing. You can see that this is our code for calculating sum of n natural numbers. After this is base case that if n will become 1, then return n value, and this is my inner function calling and my work, and finally I am returning sum of n value, right? Let us consider that n is equal to 5. So this is my, first of all, the initial control will be in my main program. So here n is equal to 5 and I am calling my sum of n number. So here n value is 5, so my one function will get called, right? Here n is equal to 5. So I don't know the value of like sum of n value of 5, right? Sum of 5. So what I am calculating? I am calculating 5 plus sum of 4. So these function will call me sum of 4. So sum of 4, here n value is 4. Now here what I am calculating? I am calculating 4 plus sum of 3. So I don't know sum of 3. So these function will call me sum of 3 numbers. Here n is equal to 3, and what I am doing? I am doing sum of 3 plus sum of 2, that is n minus 1. After here this function will call me sum of 2. So sum of 2, here n value is 2. After that I am calculating 2 plus sum of 1. So here I will calculate sum of 1. Sum of 1, and I already know that my base case that sum of 1, here n value is 1. When this value become 1, then what I am going to do? I am going to return 1 to my user. So 1 to my previous called function. So here I will return 1. From this I will calculate the return value plus n value, that is 2 plus 1. So from this I will return, that will become 3. So I will return here 3. After that I will calculate 3 plus 3. The return value is 3, right? So n value plus the return value. So 3 plus 3. So this thing will give me 6. After that here the n value is 4. So 4 plus return value, that is 6. So this thing will return me 10. After that I am going to calculate n value, that is 5 plus 10. So this thing will give me 15. So I will return 15 to my main program, and I am going to in the main program you can see that I am printing the value or the returned value, whatever the user has returned me, that value I am printing. So I am printing 15 to my user. So this is how stack calls takes place for sum of n natural numbers.